What's good? How's everybody doing? I hope your day's been good. I hope it's been productive. It's Sunday, so it's a chill day, but over here we still working. It's been a little minute since we last talked. I think it's been about a month since I dropped my last video, so I want to start off by apologizing for the delay. A couple life-changing events. Most noticeably, as you can see, I cut my hair, so it's back to high school days with that one. Relocated to Houston, Texas. Still giving you Flutter content, so you don't have to worry about that. My last video, or a couple last videos, a few videos back, I made a game in Flutter using the Flame package. I found an extension called Bonfire, which allows you to make a game, but it's specifically tailored to RPG games, such as Pokemon, Final Fantasy, Golden Sun, etc., etc. I'm going to be making a simple RPG game today using Flutter Bonfire called TheGreenNinja, and I'll explain a little bit of how that's going to go in a little bit. But for now, just know that today we're going to be making an RPG game. So let's jump into it. So as always, I like to give shout outs to the people that I watch before I start any of my content. A lot of the times when I'm starting any new material related to Flutter, I like to watch a lot of videos first to make sure I understand it before I can even try to teach it myself. The first shout out is to, and I apologize if I mispronounce your name, Sakina Abbas. She had a video related to using Bonfire. Went pretty detailed in how to use a lot of the components, so I highly recommend you check out her page if you're learning how to create games, whether it be RPG or just normal games in Flutter. The second shout out is Dev Cage. I've shouted him out before in the last video I made in Flame, but he had more content related to how to use like boundaries and tile editors and some video content that I didn't watch the first time when using Flame, but I watched it now when I'm using Bonfire. So I would check out his content as well if learning how to make games in Flutter. So the premise of the game is the Green Ninja, which is the title of the game, is going to be the main character, and he's going to traverse through the map, fight a couple enemies, pick up some life packs when the enemies drop them, because in all RPGs, enemies drop items. Get to the final boss, fight him. The boss is obviously stronger, more life, but once he beats the final boss, he gets a coin and he wins the game. Now this is very simplistic, bare bones of an RPG, but it's enough to cover all, or not all, but majority of the components that Bonfire provides. So it'll be perfect for today's demonstration. Right here we have the Green Ninja Flutter project. I'm going to go ahead and explain some of the configurations and basic setup that I have for the app. It's not the real development aspect of it just yet, but it's going to be explaining some of the variables that we'll be reusing throughout the video. I'm just going to explain them here now. But first, let's go over the pubspec.yaml file, probably the most important file of any app. We have two packages that we will be depending on. The first one is Bonfire, of course. Then we also have Flame Audio. Bonfire is how we'll be making the RPG game itself, and Flame Audio is how we will play sounds within the video game. Then there's also this assets structure, folder structure, giving the directories of where we will be placing our assets. So the assets up here, simple sounds like sound effects when enemy hits us, or we win the game, or we lose the game. These are going to be the sound effects. The images, we have this dungeon PNG. We're going to use this to make the map. We have the sprite sheets of the characters that will be within the game. I said app, the game, same thing. Some items, coins, life pack, shurikens, sword. Effects for when the players are using attacks within the game. Finally, decoration for fire when we put a fire component to our game. Okay, so those are the assets. Then we have some actual dark code here. I have the animations configs class that I made. This class simply provides the animations for all our components based on the sprite sheet and then how we want to sequence that sprite sheet. So if you see here, we have a fire animation that's going to be using the fire PNG. It's 5 units, so it's going to be sequenced in 5 steps, and the global sprite step time is 0.1 seconds. So every 0.1 seconds, that this fired PNG is going to be cycling through that sprite, if that makes sense, to give the illusion that it's actually moving. And then you also specify the size. But this is where all the animations will go. I figured it'd be easy to have this developed already instead of trying to come up with all these numbers and configurations as we're developing the game. But just know that these are the animations. There's also this collisions configs class where within the game we need to specify the collisions that happen when users attack each other, as well as when projectiles hit other components as well. So there'll be different collision sizes for that. Then this globals file where I just have a bunch of global variables. A lot of them are paths to the different assets we have, but there's also variables, like I mentioned before, the sprite step time for how often the sprites are sequencing. Then we have variables for distances for when components are observing other components and are alert now to take action within the game. Item sizes, dialog box sizes for the UI when a dialog pops up. But yeah, just a bunch of different things in here. So that's the globals. Then the enums that I'm working with. There's an enum for your attack type, melee and range. There's 2 types of attacks, obviously. You can attack close range or from a distance in the game. So we'll have this attack type enum. Then there's also this map ID enum for when we are switching between maps within the game. So if we're on map 1, we will obviously be on enum 1, and so on and so on. I'm only going to have 1 map for today's video, but for demonstration purposes, I'll show you how you can have multiple maps set up. The sprite sheets are simple classes I made to load the images, which were these sprite sheets right here, to load these into sprite sheets within Flutter so that they can be used. I just closed it on accident. But yeah, so we pass in that blue ninja sprite sheet, loads it as an image. Then we create a sprite sheet from columns and rows, specify how many columns, how many rows in that image, and then we assign it to a static variable for sprite sheet. That way we can call upon it at any point within the app, okay? And I'll show you how that looks in a little bit. And then finally, the main.dart file. This actually might be the most important file. I might have misspoke, but maybe second most important. But in here, we wait to make sure that the Flutter widget's binding, make sure that it's been initialized. Then we're loading all of our sprite sheets right here because it is a asynchronous function call to get those sprite sheets, so we're loading them ahead of time. This flame audio cache load all. This allows us to load the audio sounds before we need them in the game, because if we don't, by trying to play the sound on instance without it being loaded, there might be a slight delay and then it will look inaccurate within the game if you get hit and then you hear the explosion 2 seconds later. So we're loading the sounds now to save time and, you know, make it work. Then just a simple my app stateless widget that says how to make a game with Flutter and Flame. And here you have it right here. Oh, I forgot to mention, we're going to be making this in Mac OS, so it's a Mac OS app. So as you can see here, we can minimize it, cancel out. So it's not iOS. It's not iOS technically, I guess, but it's a desktop, a Mac OS application. So within Bonfire, you need to provide a map for the game. And you can make these maps using a tile editor called tiled.io. I believe it's tiled.io. I think it's just tiled, but either way, it's free. Just go to the website, mapeditor.org. You can download it and you can just use it like that. So I have it downloaded as an application right now. So we're going to create our map first by selecting, let me see if I can zoom in. I can't zoom in. All right, we're just going to select new map, and I'm going to make this map 30 tiles by 30 tiles. Every map in an RPG game like this is going to be based on a tile system, and you can specify the pixels, how many tiles, so on and so on. I'm gonna do 30 by 30 with width and height 32 pixels. We have our empty map right here. The first thing that we want to do is we want to add the floor to the map, because right now we don't have anything to stand on. So I'm going to go up here to File, select New Tile Set, and I'm going to look for that dungeon PNG that I specified earlier to use it as a tile set. So as you see, it was a PNG with all those components on it, and I'm going to use it as a tile set, meaning that I can pick which of those components that I want to place on this map. Okay. Dungeon underscore tile set, save as, and make sure you save it as a JSON file. Okay. Hit save. All right. Now we have this tile set to use over here in this right side. So I'm gonna select one piece of it. Actually, I'll select 8 of them, and then just come through with the fill tool and fill the whole map. Okay. I'm not gonna get too deep into what tile does, because it's I don't even know everything it does yet. I just used the bare minimum to make this map for this game. But this is how you would create the map. So we have that. We want to save the map now. I want to save it as map1.json. Make sure you save it as JSON. Okay, cool. So if we come back over within the Flutter project, you see that we have this map1.json file. All it is a JSON file with the data, which represents which tiles were used, 5, 6, 7, 8, because it was a pattern, 9, 10, 11, 12. It was a pattern of those 8 tiles, so it's a bunch of those numbers repeating. Then data about everything else related to it. So that's map1.json. So we're good as far as tile. We have our map in here, so that's good. Now we have the map within the JSON file. We need to be able to access that JSON file and load that map into our game in Flutter. So since we just added a new asset, technically, we're going to update our globals file. If I can find it. Actually, I already have it in here. I probably should have had that out for the video, but oh well. But yes, this is the variable, constant variable map1. It's just pointing to that map1.json file. Now we need to create the game instance that is going to encompass this entire RPG game. So I'm going to create a new directory, a new folder, call it games. Oops. Then call it the TheGreenNinjaGame.dart. And this is going to be a stateful widget. We'll call it GreenNinjaGame. And then we're just going to build out the Bonfire widget. So we're going to return a Bonfire widget. The map is a WorldMapByTiled, and the first param that goes through is the path to that map1.json, which is in our globals variable. So I'll call globals.map1. Then the force tile size param is going to specify what the size of the tiles will be within the Flutter app. And we're just going to have that as 32 by 32. I also need to add the joystick to the game. Joystick directional. And the linter's always complaining about this, but we need to make that a constant. Okay. We have the Green Ninja game set up. Now we need to come over to the main.dart file and pass in an instance of that Green Ninja game to the material app. So we'll take this out, call the Green Ninja game. And now, if we restart the app, come over, you'll see that we have our map right here, okay? 30 by 30 tile that we just made in tile.o is now in our Flutter app. Got the map in there, but the map is empty right now. Perfect time to add the main player, the Green Ninja. Let's go over to the lib directory, create a new directory called players. Even though there's only one player, technically wouldn't even need a directory for it, but this is how I had it set up. So we're going to call it Green Ninja player dot dart. Okay. Class Green Ninja player extends simple player, and the simple player is just a basic player component provided by Bonfire. It has things such as life for the character, the size of them, the initial position that they're facing, their sprite, animation class, how much damage. No, that's not on there. That's something you create. But yeah, just a few components, and I'll show that right now. I'm going to make the constructor, and I'm going to pass in. I need 2 required parameters for the constructor. I'm going to need the position of where this component, the Green Ninja player, will start. So we're going to make a required vector2 position, and then I also need the sprite sheet because I'm going to need it to provide the animations to take place. So I'm going to pass in the sprite sheet for the Green Ninja in the constructor, and then in the constructor is going to be able to build the animations. So required sprite sheet, super, and this is where I can specify the position. The position is going to be that position that we pass in from the constructor. Size is going to be globals. We have a global variable for the size of the players. Globals dot player size. All right, we need to add a few more things. Let's see, speed, we'll just keep them at 100. Life, keep them at 100. The initial direction dot down. So this is saying that the first direction when he's on the screen is the down sprite that we specify for this character. And then finally we need the animation, which we're going to call our animation config. All right, and let's do that import, and then we're going to pass in the animation for Green Ninja animation, which takes in that sprite sheet. Okay, I'm gonna show you what that looks like again. So it's taking in that sprite sheet, and then based on where we're at in the sprite sheet, when to display it based on the sprite steps, it's just sequencing through the sprite sheet to give the animation. All right, so we don't need the constructor just yet, but we have everything for the Green Ninja player. Now we need to go ahead and add him to the game. So we'll come back over to the GreenNinjaGame. Within the Bonfire widget, we'll call the player param and pass in Green Ninja player. And we need to specify a position. We'll just do 40-40, so that means he will start at 40 pixels to the right, 40 pixels downwards. Okay, just top left corner essentially. And then the sprite sheet is going to be the Green Ninja player sprite sheet. No, Green Ninja sprite sheet dot sprite sheet. Let's refresh that. Cool. So we got our character now. Okay. Something to keep in mind. If you remember, when we don't have the player attached, let's refresh that. Okay. Oops. When we don't have the player attached, moving the joystick allows us to just traverse through the map. So this is good when you're actually building the map and you want to look at it and see how it looks and all that. But when you actually have a player now attached to the Bonfire widget, the joystick automatically becomes mapped to that player. Okay. So here we have our player, the Green Ninja, left, right, up, down. Okay. He's in there. The Green Ninja player is in the map. Now we can go ahead and add an NPC to the map as well. So within RPG games, NPCs are non-playable characters. They usually serve the purpose of, well, they usually have a wide variety of purposes, but you can use them when you need to let the main player know what's next in the map, any hidden items, selling items to them, giving them hints of where different things are in the world, so on and so on. So we're going to have an NPC called Old Man, and he's going to give us some information about the coin that we need to collect. So first thing we need to do is we need to add him to the map. So we'll go back to tile.io, and I'm going to create a new tile set, And we're going to find the sprite sheet of the old man. This is within the directory of the project I'm working on. So these are the assets in the Flutter project. I'm going to open that. I'm going to change the tile width to 16 and tile height to 16 because that sprite sheet has those sprites at 16 by 16. And then I'm going to save this as old man tile set. And be sure to save it as a JSON file. It's already in there, but we save it again. So now I can come here and insert one of these sprites onto the map. But first we need to create a new layer. So tile layer 1, as you can see right here, this is the base layer, the floor layer. So we want to create a new layer. We could just hit control click object layer. And now we come to this drop down at the top that says insert tile. And now I can pick one of these sprites and place him on the map anywhere I want. So I'm just going to put him right here. Make sure that you change the name of that sprite that you just placed to whatever you want to map it to in Flutter. So I'm going to be, because it's mapped by key value pair pretty much. So I'm going to be looking for old man within Flutter when I need to figure out the position of the old man NPC. So save that, then save the map. If we head back over to Flutter, we can look into our map 1 and we see that we have this old man object on our map now with his coordinates, okay? We can now go to create a new directory called NPCs. Similar to players, this is going to be all the NPCs in the game. We'll just have one for this example, which is the old man. So we'll call this old man NPC.dart. And he's going to have a lot of the similar properties as the Green Ninja player, which extends the simple player. The only difference is the old man NPC is going to extend simple NPC. And we need to change this to old man NPC. And like I said, very similar to simple player, except the NPC doesn't have life. So that's why we have this error, because there's no life field on the simple NPC. Then we need to change the animation to old man animation from our animations configs. I think everything else looks right. Now we need to go to the game, and when we're adding NPCs or enemies or items to our map, we need to use a function called objects builder, where we map the name of the object that's on that the map1.json file to a component that we've created within Flutter. So I'll show you what that looks like. So within the WorldMapByTiled, we can call the objects builder, which takes in a map, and we need to first specify the first key of our objects list, and that one is the old man. Remember, we saved that component on the map as old man, so that's what we're looking for in here. And pass in a properties field, which is a object of type tile properties. That just tells us some of the properties that are on that object field in the JSON, such as the position is for what we need. So now we can just return, pretty much we're saying whenever there's an instance of old man, we want to return an old man NPC, and that position is going to be on the properties object, or the properties field, properties.position. Let me import this as well. And then we need to pass in the sprite sheet for the old man. So we'll import old man sprite sheet.spritesheet. If we refresh this, we should now see the old man NPC, and he's currently chilling. We got the NPC in there now. So with the NPC, we want to be able to have him communicate with the Green Ninja about the information about where the coin is. So now we're going to add a feature that allows you to tap on the NPC and start a conversation with him. Kind of how it goes in Pokemon. Character on the left side talks, then the character on the right side talks, back and forth until the conversation ends. So within the old man NPC, we're going to extend or actually add a mix in called tap gesture that allows us to be able to tap on the old man NPC component. So we'll call tap gesture, and that's going to give us this method called onTap. And what we want to do in onTap is call a method called show dialog talk, which we'll build out in a second. first thing we need to do, well, not the first thing because we already made a couple steps, but we need to create a helper method that's going to create each speech component within the dialogue. So within the dialogue, there's going to be these objects called say. So we're going to have a method that returns a say object called speak, and it's going to take in the text of what's being said, as well as a boolean to represent if the person talking is the main character or the NPC. So we'll just call it is hero. So it's going to return a say object. The text will be the text. Text is a text span. So we'll pass in, need to import material. Actually, text is an array. Text span, text, text. Now that's a very weird and wild way to set that up, but yeah. All right, so we got the text. Then we need to specify the person, which is just pretty much the image of the person that's talking. It's just a widget. So we'll make it a size box. The height is going to be one of our global variables, not default tile size. Dialog box will be dialog box as well. And then there's also the child, which is going to be the image of the person that's talking. So we're going to be checking if the person talking is a hero, which means it's the Green Ninja. Then we're just going to call the first sprite on that Green Ninja sprite sheet. So call Green Ninja sprite sheet. There we go. Get the sprite at row 0, column 0, and then call as widget. Okay. Finally, there's this person say direction, which is going to just determine which side the character is of the dialog box. So if it's the hero, then we're going to be talking on the left side. So if is hero, direction, actually person, say direction, dot left, otherwise person, say direction, dot right. Oh, and I forgot to add the other part of this clause up here. So if it is the hero, it's the Green Ninja, otherwise it's the old man sprite sheet. Okay, that looks good. Now we can go ahead and define the show dialog talk method that I spoke of earlier. So we'll create the void method called show talk dialog. So within here, some cool things that you can do with Bonfire is you can also mess with the camera. So you can make it zoom in, zoom out, focus on different characters directly. So when we hit show dialog talk, we're going to zoom in on the NPC. So within the show dialog talk method, we're going to call GameRef.camera.move to target animated, and which is going to be this, basically saying that we're going to move to this, which is the old man NPC. We're going to be zooming in on him. Zoom will be 2. Finish is what we're calling once we're done zooming in, and this is when we'll actually start the conversation. So we'll call talk dialog.show, pass in a context. Actually, it should be the GameRef.context. Then we need to build the array of speak objects, or the speak object. So we're going to call that speak method. So the first thing that they're going to say is the conversation will start with the old man just saying what's up to the Green Ninja. Hey, what's up, Green Ninja? Are you lost? And is hero will be false because it's the old man talking. So then the Green Ninja will respond, hello, old man. Pleasure seeing you. Do you know where the coin is? And is hero will be true this time. Okay. Next part of the conversation. The old man is responding. He says, yes, the blue ninja has the coin. That's going to be the final boss. So we'll have that is hero as false. And then finally, the Green Ninja, since he knows where the coin is now, he's just going to say less. We'll have that as true. Then we need to specify the logical keyboard keys to next. So this is the keys that you can press on the keyboard to progress to the conversation. Logical keyboard key dot. I should be able to import this. There we go. So we're going to use the space bar as well as the enter key. And you can pick whatever keys you want, but these are the most common ones that I've seen. All right, so that looks about right. If we refresh this, come over to the game, we should now be able to tap on the NPC and the conversation starts. So you can see down here, it says, "Hey, what's up, Green Ninja? Are you lost?" It shows the old man on the right. Then we have the Green Ninja responding saying, "Hello, old man, pleasure seeing you. Do you know where the coin is?" The old man says, "Ah, yes, the blue ninja has the coin." Green Ninja says, "Say less." Conversation ends. Oh, that's one thing I gotta do. We need to move the camera back out because it never zoomed back out. So within here, within the talk dialog.show, there's an on close method. And this is where we can call the camera to go back to the player. So we'll just call GameRef.camera, move to player animated, and the zoom will be 1. All right, let's try that one more time. Perfect. The NPC is in the game, he's chilling, but he's not making any movement right now, so that's not realistic. So what we want to do now is provide him some functionality to make his own movements when he needs to, as well as throwing up a message saying, "Hey, Green Ninja," when he's within the vicinity of the Green Ninja. Once he spots him, we want to throw up a message. So first things first, we need to add a mix in called automatic random movement. This is going to allow us to use some methods that will allow the NPC to make movements on his own. We also need a variable called is observed, or just observed equals false. This is going to be the variable that represents if the old man NPC has observed the Green Ninja within his vicinity. Then we have a late text paint object, which is going to be what is used to create the message saying, "Hey, Green Ninja," when he is observed. We can actually create this in the constructor of our old man NPC. So text paint will equal a text paint. And the style will be text style. Color will be colors.white. Font size will be the width of the NPC, old man NPC, divided by 2. Okay. Good. So that's there. Now we need to override the render method. This is the method that we're going to use to actually render the message saying, "Hey, Green Ninja," onto the screen. So call override void render canvas. Call our super method, pass in the canvas. Then we need to check and see if the NPC has observed the Green Ninja. He'll display the message. So we'll check and see if observed. We'll call the text paint.render, pass in the canvas. The message will be, hey Green Ninja. And the position, we're going to say vector 2, it's going to be position of the component x coordinate minus 30 and the position coordinate for y minus 30. We also need to update the update method. The update method is called during the game loop. So the entire game loop is just literally a loop going continuously for the entire execution of the program for the game. And the update method is where you can actually modify the sprite to do whatever you want during these iterations of the loop. So call override void update double DT. Call our super method. Now here is where we will call a method called see and move to player. Now what this does is It's going to have a callback function on here to let us know if the old man NPC has observed the Green Ninja, and if he has, he's going to go towards him and follow him. So kind of like in Pokemon games, when you get close enough to a certain NPC, they kind of walk towards you to give the feeling that they have something important to tell you. So it has a few other callbacks like close player. You can do something with the player, but what we want to do is we want to modify the vision, radius vision. This is how far his vision expands to even detect the Green Ninja. That's a global variable for radius vision. Then we have an observed callback, and this is what we'll take action here when the old man actually observes the Green Ninja. So if observed is false, which means he hasn't been observed yet, then we're just going to set him equal to true. Likewise, if he's not observed, not observed, then we're going to set observed equal to false. Now mind you, update is always running, so he's always going to check, is he within the boundaries, is he not, is he observed, is he not, and it's going to be setting these variables accordingly. Also, when he's not observed, we want the old man NPC to be making those random movements that we specified earlier with the mix-in at the top. So we'll call a method called run random movement, passing the DT from the update method. Then we can also specify the max distance as far as how far the NPC will walk away. And that's a global variable as well, called observe max distance, as well as min distance, observe min distance. Okay, let's refresh that and see what that look like. All right, so we see the NPC, he's making his random movements. He's in his own little world, just walking up and down. If we get within a certain range of him, he throws up the message saying, "Hey, Green Ninja," and now he's following us, okay? So you see how I'm walking away and he's still following us. I shouldn't have made him the same speed because now I can't get away from him. I'm gonna change that real quick. I'm just gonna make my green guy a little bit faster, so his speed will be, we'll just give him a speed of 200. Otherwise I'd never be able to get away from him. Okay, there we go. So now you can see when I'm away from him, he's making random movements, but when I get close, he says, "Hey, Green Ninja," and that's when, you know, we can tap on him and talk to him. Cool. The NPC is on the map, he's moving and talking, but now it's time to bring in some challenges to the game, and by challenges I mean some enemies. So the first enemy that's going to be presented is the Dark Ninja, which is essentially just the Green Ninja, but he's dark, okay? So in order to do that, we need to come back over to tile.io, create a new tile set for the Dark Ninja. So we'll browse to that Dark Ninja sprite sheet, open that, specify 16 by 16, Dark Ninja tile set, save it as JSON. Okay. Now we come to the object layer and we want to insert some Dark Ninjas onto our map. So I'm gonna just put them in 3 random places around the old man. All right. And I need to change the name on all of them to Dark Ninja. We save the map. Now within Flutter, we have our ninjas on the map. We can go ahead and create the actual enemy now. Within the lib directory, a new folder called enemies. This one will be called Dark Ninja enemy.dart. It's going to be similar to the Green Ninja player. So I'm going to copy and paste that. Call this Dark Ninja enemy. He's going to extend the simple enemy class. And I want him to have the random movements just like the NPC, the old man NPC had. So we'll do the same thing, add with automatic movement, automatic random movement. And I'm gonna copy and paste that whole update method to allow the Dark Ninja to take on the same thing, same properties as far as the random movement that the old man NPC is doing. So we'll put that in here. We need that observe variable for him as well. Cool. Refresh that. Actually, we need to add them to the map too. So come back to the game, to the objects builder. And this key is going to be Dark Ninja. Pass in the Dark Ninja enemy class. And we need the Dark Ninja sprite sheet down here. Let's refresh that and see how that looks. So we have the 3 Dark Ninjas on the map moving around. As you can see when I'm moving, they, I forgot, okay, they're moving really fast. I forgot they're a direct copy of the Green Ninja, so I'm gonna slow them down just a little bit because I don't like them moving that fast. That's not what we're trying to do. We're gonna put them back at 100. Let's refresh that. I gotta make sure the Green Ninja can get away from them, just in case I don't feel like fighting. I gotta be able to get out of there. All right. So, whoops. Move down. All right, cool. But as you can see, when I come in close vicinity, they all follow me until I get away. So that's working good. With the enemies on the board, of course we can see them, but now we gotta be able to see what type of life they have, how much damage they have, or not how much damage they have, but how much damage we've done as the main player. Good thing for us, Bonfire provides a good mix-in for that called use bar life. So we'll just add that to the Dark Ninja up top, use bar life. Then within the constructor of the Dark Ninja enemy, we'll call setup bar life. The first property that we're going to add is show text life false. This is going to be if we wanted to show how much life was in text form, like 100 out of 100 on the life bar. But I don't like doing that. I'd rather just show a color bar that's depleting as damage is taken. So show life text equals false. Border radius of the life bar is going to be border radius circular 2. Then border width 2. Let's refresh that, see what that looks like. Cool. So now the 3 enemies have the bar life. The enemies are on the board. They have the life bar. So that means that we should be able to see when they actually take damage now. So with that being said, we can go ahead and add some attack methods to the Green Ninja. So first we need to add some buttons to our HUD, HUD, which is going to be technically the view that we see as the player of the game. And it's going to be the buttons for melee attacks and range attacks. So back in the joystick within the TheGreenNinjaGame, I need to call keyboard config. Then I need to specify keyboard directional type. That's going to be WASD and arrows, and that means that for movement in the game, you can use the keys WASD, which is on the left side, as well as arrows up, down, left, right on the right side. We also need to specify the accepted keys because we want to be able to hit these keys when we're making the melee or range attacks. So we already have the input, the keys I just mentioned earlier for directional input. Now we need keys for the attack input. So the accepted keys that we're going to use for that one are logical keyboard key, logical keyboard key dot, let me import this first. We're going to be using the numpad enter key. So that's the enter key on the far right of the keyboard, as well as the 0 key, the numpad 0 key. That's in there how it needs to be. So Now we need to add the joystick actions, which are going to be the actual buttons that we see displayed for performing the melee or range attack. So go to actions, the actions param. I think that's outside, it's in the joystick widget. Yeah. So we have one joystick action, which is going to be for the melee. So we're going to use the melee enum as the action ID. The size is going to be 80. Margin will have, it's going to be on the bottom right, but we're going to have it 50 pixels from the bottom, 50 pixels from the right. So bottom, oops, wow, that is a wild. Also specify the alignment, which will be joystick action align bottom right. And last but not least, we need to specify the sprite that's going to be used. So we'll call sprite.load globals.sword because it's going to show the sword as the melee attack. And we can just copy and paste the same method or the same object again for the range attack. Make it a smaller size, probably like 50. Make this go 160 pixels from the right, so it's farther to the left. We can get rid of the align. And the sprite for this one is the shuriken single. The shuriken is the thing that the ninja throws out, little sharp things. So if we refresh this, you can see on our HUD, we now have the shuriken and the sword. We have the Dark Ninjas on the map with the life bars, so that means we're a step closer to being able to actually take some life away from those life bars. So now we're going to add some attack features to our Green Ninja player. So we need to first specify how much damage the Green Ninja player can do. So we'll create a variable called damage, which is a double, and we'll give him a power of 10. So in the bigger scheme of things, the melee attacks will be twice as strong, so they'll do 20, and then the range attacks will just be 10. Now what we need to do is override the joystick action event. That way we can map those keyboard presses or on-screen button presses to the attacks that we're going to create here in a second. So override joystick action event. And within here, the first thing we need to do is check if the event equals action event down. And what this is checking for is whenever we press on the keyboard, there's technically two actions. It might be more than two, but it's at least two. When you press down on the key, that's considered one event. When you let up from the key, that's considered another event. So we're doing a check here to make sure that we only perform the attacks when the key is pressed down. Otherwise, if we press down and up, we would fire the attacks twice, and we don't want to do that rapidly like that, right? We want to only attack when we press the button down. So within the check for action event down, now we can check and see if which button was pressed, the sword or the shuriken, or if it's the keyboard, was it the 0 or the enter pad. So in here, if event.id equals attack type dot melee, whoops, let me import that. Damn, I can't get it. There we go. All right. So if attack type is melee, or if event.id equals logical keyboard key dot numpad 0, let me import that. Numpad 0 dot key ID, that means that they pressed the sword or they pressed the 0 key on the numpad. So within here, we will perform or do our melee attack. Okay. Another thing to also check for is we want to make sure that the player is still alive, because if he's dead, we don't want to accept any actions. So what we can do here is if GameRef.player does not equal null, and GameRef.player is dead equals true, then we return, and we don't allow the method to continue. So we can copy and paste this whole jargon one more time for the range attack. Just change the attack type to range. This time the keyboard would be the numpad enter. And we perform our range attack. All right, let me also add our super method in here. Super joystick action event. Okay, so now we can go in and actually provide the attacks. So for the melee attack, we call a method called simple attack melee. The damage is going to be the damage times 2 because it's a little bit stronger when he's up close. Size is going to be vector 2.all, and we'll just make it the same size. Actually, no, just passing the size. So it's going to be the same size as the Green Ninja component, or maybe a little bit smaller. Either way, it's going to be a decent size. Okay. We also need to specify the animation for it. So the animation right is going to be in our animation configs, and it'll be the cut animation because when he uses his sword, we're going to see the cut effect. Let's see. And there's also a with push param that you can add that will force the enemy to be pushed back if he's attacked. So it's a little more realistic than instead of having him just stay in the same spot if he's being striked 10, 20 times. You can give him some pushback, but we'll keep it false for now. Okay, so that's our simple attack melee. Now we need to do the same thing for simple attack range. Now this one requires animations for right, left, up, and down. I'm not sure why. For the attack melee, it only requires animation right. But yeah, for these we need to specify, but we can use the same one over and over again, but we just need to specify it this way. So go to our animation configs again, animation configs. And for the range attack, we'll be shooting out the shuriken. So call the shuriken animation. I'll put this in here. Ooh, I messed up somewhere. Yeah, I copied too far. There we go. Okay. And the damage is going to be the damage. All right, let's refresh this, see what this looks like. So I'm on the keyboard, hit the 0 key, I got my slash, hit the enter key, I got my shurikens, okay? Perfect. The Green Ninja is attacking properly. However, the Dark Ninjas aren't taking any damage yet. That's because we have to implicitly explain what happens when the Dark Ninja is receiving damage, okay? In order to do that, we go to the Dark Ninja enemy class, and we're going to override a method called receive damage. Override void receive, I always spell this wrong, receive damage. It takes in an attack from enum, attacker, double damage, and a param called identify. Call our super, receive damage. So now what we need to do is, we don't really care about the attacker or the identifier. We just need to do two things on receive damage. One, we need to display the amount of damage that was just taken, as well as play a sound to let us know that the Dark Ninja has been hit. We can do that by calling the Flame Audio class, play an explosion sound. Now I know this isn't the most accurate sound to play when you get hit, but this is what I got. Then we just call a method called show damage, where we pass in the damage amount, and we can modify the config, which is just the text style, to be a little bit smaller because we don't want the amount of damage to be shown to be too big. So we'll just do 1/3 of the width, and we'll make the colors.red, Red. Let me import that. Cool. So if we refresh this, we should be able to attack the ninjas with the melee. Okay, cool. So, perfect. So the shurikens aren't working still because we only apply the melee, but you see when we hit them, it shows how much damage they're taking. I do 20 with the melee, so you see the 20 pop up. I don't know if you can see it or not, but, and their health bar goes down. Okay, so received damage works for the melee attack. Melee attack is taking damage for the Dark Ninja. So all we gotta do for adding the range attack is provide object collision. So it's a mix-in, thankfully. Call object collision. And then within the constructor, we'll just come down, call set collision, setup collision. And I'm going to call my collision config in my collision config class. This one is going to be for the player. Oops. Collision config, no, collision configs. Collision configs dot player collision config. All right, so now refresh this. The shurikens that we're throwing, I hope I'm pronouncing these right, but the items that he's throwing, it should attack the ninjas now. Yep. So they do 10 damage. The melee is 10. Get out of there. Look. Alright, that's working. The Dark Ninjas are taking damage and their life bars are depleting, but you can see that they're actually not being removed from the screen. They're not actually dying. So, simple way to fix that, override the die method within the Dark Ninja enemy class. Go right below receive damage, call override, void die, super.die. Then, two things we want to do is, when the Dark Ninja enemy dies, we want to shake the camera a little bit to let the user know that they've just been killed, as well as remove the Dark Ninja enemy from the view. So we're going to remove it from the parent. So the first step, we can do this by calling GameRef.camera.shake. Oops, shake intensity. Shake intensity 4. And then we're going to remove from parent. Let's refresh this. Now if we run up to Dark Ninjas, they actually die, okay? So they take damage from melee and close attack. So the Green Ninja can attack the Dark Ninja, but right now the Dark Ninja cannot attack the Green Ninja. We need to fix that, of course. We can go ahead and do that now by adding some attack capabilities to the Dark Ninja enemy. In here, we have this observed Boolean variable that I copied from the old man NPC, but we don't need the observed variable. We need a slight modification of it. Something like C player to attack melee. This variable is going to be used to let us know if the Dark Ninja should be using melee attacks or range attacks, okay? And then we also need to give it a variable for how much damage this class or the Dark Ninja can do. Okay, so we'll come down here to the observed, take these out because we're not using those. And also, something that would be good to do in the update method, since it's called continuously throughout the game loop, we should do a check to make sure that the scene builder isn't running. That means while the actual map is assembling all the objects and enemies, we want to make sure that these enemies can't attack the player. So if GameRef.SceneBuilderStatus.is running, if that's false, then we can continue on with our approach. So First thing we want to do is we want to set this variable to false on default on every update call. And we only want to set it to true when the player observes, or when the Dark Ninja observes the Green Ninja. Also, when the player is close enough, we want to check and see if the player is not dead. That means we should go ahead and perform the melee attack. And we'll take out this not observed on this part. Now, oops. So, after it tries to see and move to player, if the C player to attack melee is false, which means it was never observed, but it could still be within the distance to do a range attack, then we're going to do the range attack instead. So if C player to attack melee is false, we're going to call C and move to attack range. In position is a player. Oops. So min distance from player, this is going to be the minimum distance that the player, the minimum distance that the Dark Ninja enemy can be from the player to perform the range attack. So we'll just say globals dot default tile size times 4. I could probably find a better variable for something like this, but essentially just be 4 tiles over, and that's the minimum distance that he can be for the range attack. Also within here, same thing as up here. If the player is not dead, then we'll perform the range attack. Then we specify the radius vision. We'll do this times 2. And finally, we're going to move that not observed that was up top. We're going to move it down here into the C and move to attack range. Okay. So we got our setup right there. Now we just go ahead. Now we need to just add the attacks for melee and range. So we can copy that by going to the Green Ninja player, copy simple attack melee. We're going to paste that in here. That looks right. Then we want to also copy simple attack range, and we're going to put it in here. Now the difference is the simple attack range within the enemy class, the simple enemy class, which we instantiated from, doesn't have all these animation left, up, down. It just has animation right and animation destroy. And animation destroy is the sprite animation for when a projectile actually comes into contact, or when the Dark Ninja enemy comes into contact with a projectile. So I have a smoke animation that we'll be using for that. Animation configs dot smoke animation. And then we also need to specify the collision for when the Dark Ninja enemy throws out its shurikens. We need a collision config for when it lands, it hits us. So collision config, collision configs dot projectile collision config. Cool. So if we start this looks good. I think that's everything. One thing I noticed, I had two different shuriken animations. I want the Green Ninja player to use the magic one. I just noticed that shuriken magic animation, because they should be throwing different items. So let's restart this and see what this looks like. So, all right, I got my different shurikens now. Now let's see if they throw theirs. Oh, okay, he's fighting me. Got the melee, and he's throwing it. Okay, cool. So yeah, you know when to attack melee and when to attack with the shurikens. See how he goes right here to throw the shurikens, and then when he's close enough, he does the melee attack. And the reason he walked away is because I'm dead now. Yeah, but I don't have a life bar, so that'll be the next part where we'll add a life bar to the Green Ninja. So like I said, I'm going to add a life bar to the Green Ninja now. So pretty much just going to do a little bit of copy and pasting. So we need to add object collision to our Green Ninja player. Then the setup collision and setup bar life. We'll just put that in the constructor for our Green Ninja player. Add the imports. I also need to add the use bar life mix in. Use bar life. I think that's all I need. Yeah. Then I also need the receive damage. Where is that at? So we'll put the receive damage for the Green Ninja in here. Yeah, same thing. Plays the explosion sound. There is one little change in here that we do need to add. Is we need to check what type or where the damage is coming from, like what type of attacker. If attacker equals I can't speak today. If attacker equals attack from .enum enemy, so there's two options. You can get attacked from either a player or ally or an enemy. So we only want to receive damage when it comes from an enemy. So we'll put that check right here. And then we'll perform the same logic as when the Dark Ninja enemy receives damage. Also want to take this die method and put it in here as well. Now ours is going to be a little bit different. Well, it's essentially the same. The only difference is we want to play a game over sound if our player dies. Let's see what this looks like. So I got my life bar. Taking damage. See? Alright. Play the game over sound for me. Let's do that one more time. They got me quick too. Alright, just like that. So I got the Dark Ninja enemy, right? But I'm gonna add a few more enemies to the map to make the game a little bit more interesting. So we have to add a demon Cyclops, or Cyclop, however it's pronounced in its sprite sheet, as well as the blue ninja, which is going to be the final boss. So we'll go back to the map. Same as always, we're going to create a new tile set. We want to look for that demon Cyclop. Okay. Now this one is going to be tiled with 50 because this sprite sheet is a little bit bigger. So call this tile set .json. Then object layer. Place one of these, probably place them right here. And then we'll change these names to demon. All right, perfect. Also need a tile set for the blue ninja. He's gonna be 16 by 16, so we'll bring this back down. Go to the blue ninja sprite sheet, tile set, .json. Look for it on our tile set. Insert object layer. We'll put him like right here, and we'll call him Blue Ninja. All right, save that. Whoops. Cool. We're done with tile.io. Now we need to just going to do a lot of copy and paste, but we're going to create a new enemy. Call it Blue Ninja enemy .dart. Copy and paste from here, from the Dark Ninja enemy. But we're gonna make the Blue Ninja enemy a little bit stronger. So his damage, default damage, will be 20 because he's the final boss. We're also gonna make his life 200 and give him a speed of 150. But everything else is gonna be the same. Yeah. Oh, and we're gonna change his range attack to be a energy ball. Okay, so that's the Blue Ninja enemy. That's done. we need demon now, so we'll call demon enemy dot dark. Copy from the dark ninja enemy again, and we'll call this demon enemy. We'll keep his damage 10, speed. Actually, we'll make his speed. No, we'll make his life half of. Yeah, his life is half of normal, but we'll increase his speed to 250. Just make him fast as heck, but he don't live long. All right, and his animation for his long range attack will be a fireball. Okay, I think everything in here is accurate. So then we need to go back to the game and put this on our map. So the Green Ninja Game. Change Dark Ninja to Demon, and we'll pass in the Demon enemy, which uses the Demon. That one, actually, I don't think the Demon, yes it does. Does it use a sprite sheet? Demon, maybe it doesn't. No, it does. Hold on, let me see. I got too many windows open. Let me see, sprite sheets. Actually, no, it doesn't take a sprite sheet. Or does it? Oh, I'm tripping. It doesn't take a sprite sheet. That's right. This one was set up a little bit different. So the animations for the demon Cyclop animation don't require a sprite sheet to be passed in, because we're sequencing the movement of the demon from a single sprite sheet. Like, how do I explain it? It goes through one single image. I'll show you. It's better to explain it through image. So it's sequencing through this movement right here when it's walking versus us trying to sequence a sprite sheet. So with this, we had to be way more technical with the sprites that we're using at different moments of each step. But this one, we don't have to use an actual sprite sheet. We just load this and sequence it. So pretty much it's a little bit easier when it comes to how we're configuring our demon enemy. So back here, we'll have the demon. Oh, we don't need the sprite sheet, like I said. And then for blue ninja, we'll pass in blue ninja enemy and use the blue ninja sprite sheet. Okay. Refresh this, see what it looks like. All right. Oh shoot, man. I can't get away from him. He's too fast. Too fast. Made him too fast. Golly. All right. I'm gonna slow him down. I didn't think he was gonna be that fast. Where he at? Put him at. Matter of fact, yeah, just go to 150. 150. Keep it 150. Refresh that. Let's see, that's better. Okay, cool. Cool. Got the blue ninja over here, boss, on the big energy. Feel me? Oh, my long range aren't working. Why not? Why my long range working? I don't think I have the collision config set up for the green ninja player. Yeah, I do. Oh, for my range though, I don't have the collision. I need the dark ninja enemy. Let me go get that collision real quick. Put that on my guy for his range attack. Alright. Here we go. Back in the game. Alright, so as you can see, we got the demon on the map. Got the boss, the blue ninja, and we got the dark guy. See if I can get him. There we Green Ninja player is attacking, he's taking damage, he has no way to revive himself, right? We can add a little item feature to the game called game decorations that will allow the Green Ninja player to pick up a Medipack to revive some of his life. So let's go ahead and demonstrate that. We'll go into the lib directory, create a new directory called decorations, and this one is going to be called medipack.dart, and class Medipack extends a game decoration. And game decorations are just anything in the game, like it could be a treasure chest, it could be a lever, it could be a torch that's producing light, which I'll show in a little bit. It can be a wild variety of things, but by default it's just like a static image. But we're going to add a mix in called sensor that allows us to detect when the Green Ninja player comes in contact with this item. So then we can do some extra things like revive our life as well as remove the item from the view. So we'll call sensor, and then we need to tie the object that has the sensor to it, which is the Green Ninja player. And we'll add that override right now. But first, I need to specify how much life this Medipack is giving the player when they pick it up. So it'll be a double variable of life, and we'll revive 25. Also, we need our constructor, and we're going to pass in the position of the Medipack from the constructor, because when we call it, we're pretty much allowing the enemies to drop this item. So when they die, we'll take the position of the enemy that was just killed and pass that position into the Medipack. So it's essentially replacing the enemy that just died. So required vector to position, and then call super dot with sprite. So now we need to specify the sprite of the Medipack called sprite.load, which is going to be globals.medipack. Position is the position that's passed in, and the size is going to be vector2 all globals.small item size. I think I got an extra. All right, cool. So now we need to go into the on contact method, and what we're doing here is essentially, well, first we need to play the sound, that a power-up sound, to let the user know that they just picked up the Medipack. So we'll call flameaudio.play globals.power-up sound. Then we want to remove the Medipack from the view because it's been picked up. And then we also want to add to the main character's life. So we'll call gameRef.player.add life, and we're going to pass in that life variable up top. And we need to make sure that we add the exclamation mark, because we would guaranteed have a player object if we're picking up a Medipack. Otherwise, we can't even come in contact with it. So, all right, that looks good for the Medipack. So now what we need to do is we need to make it so that the enemies, the Dark Ninja enemy and the demon, drop these items when they die, but make it a 50-50 chance so that it's not guaranteed that they'll drop it. So if we go to the Dark Ninja enemy, to his die method, we can create a 50-50 boolean called drop pickup. It's going to equal random dot next bool. So that's going to give us a random boolean each time. And if drop pickup, then gameRef.add Medipack, and the position is going to be the position of that Dark Ninja enemy once he dies. Perfect. And I'll just copy this into the demon enemy as well for his die method. And add those imports. Refresh this. Let's see what this looks like. So it should be a 50% chance that they drop. Okay, he didn't drop one. Okay, he dropped one. So there's the item right there. If I pick it up, play the sound and revives my life. I need another one. Let's see if he'll drop one. Perfect. Okay, Medipack working as it needs to. So we got the Medipacks that the enemies are dropping, but we need the final boss, the blue ninja, to drop the coin, which is the item that the green ninja is looking for from the very beginning. So this is going to be another decoration. So we'll come into the decorations directory, call this coin.dart, and it's going to be very similar to Medipack. So we'll just copy and paste this over. Call this coin and take out this life because it's not adding any life. Also, this is going to be super with animation, not with sprite, because this game decoration, the coin is going to be rotating, so it's going to be animated. The Medipack was a static image, it didn't need animation, but this one is going to be needing animation. So super dot with animation, and the animation will come from our config class, animations configs. Add the import, and we'll use the coin animation. Position is going to be the position of the blue ninja when he's killed, and the size will be vector2.all globals.small item size. All right, perfect. And so for the on contact, instead of playing a power up sound, we're going to play the success sound, just meaning that you won the game. So it's going to play that sound. And that's everything for the coin. Now we need to come into the blue ninja enemy class, and within his die method, we're going to add the coin to the screen. This won't be 50-50 chance. This is guaranteed. If you kill the blue ninja, the coin will present itself. GameRef.add coin and position. Refresh that. And let's try getting that coin now. So I'm gonna try to skip past them. I can run through it. Alright. It hit him from a distance. Dang, he couldn't wait. Bro, chill. Alright. I'm gonna hit him from a distance. He's pretty strong. I might charge in. Alright, see? Got the coin. Now we pick it up. Plays our winning sound. Perfect. Next component that I want to discuss is how we can apply lighting to the game. So within RPGs, you may go into a dark cave and the entire map might be kind of dim, and then you can see maybe faint areas of light where there's different torches, or maybe your NPC or character has some type of lighting attached to them as well. And we can do that by adding a lighting mix in. But first, I want to add some torches to the map. So I'm going to go back to the map, hit new tile set, look for the fire PNG, call it tile set .json. Okay, and then within our objects, insert, and I'm just going to put this flame just in some random areas. All right, as usual, make sure that we give each of them a name. We're going to call them all fire. Cool, everything's done on that side. Now we need to come into decorations and make a new decoration called fire. And it's an animation, so it's going to be a similar decoration to the coin. So we'll copy and paste that one. The difference is with fire, it's going to still have a sensor, because when we come in contact with it, we want to take damage. So we will add on to that. So create a damage variable, double damage equals 5. change this to fire animation. And when you come in contact with it, it should play the fire sound as well as the player should take damage. So we'll call game ref dot, actually, whoops. We're going to call the component, but first we need to set the component to a Green Ninja player, because right now the game component can be any type of component, I believe, but we need to, in order to give the remove life method that is used in the use bar life mix-in, which is only applied to the Green Ninja player, not the game component itself. So in here, we can now call component.show damage and just pass in that damage variable, as well as remove life on the player itself. Refresh this, see what this looks like. Oops, I gotta add it to the map. The TheGreenNinjaGame. So everywhere we have the fire, we want to add the fire decoration. It doesn't need a sprite sheet. So now we should see the fire. Okay. And if we walk into it, 5 damage. They murdered me. All right, the fire is working, but now we want to add some lighting to it because that's the real purpose of fire. So if we come back to the fire class, we'll add another mix-in called lighting. And within the constructor, we'll call a method called setup lighting and pass in a lighting config. And the color is going to be colors.yellow with, I need to do the import. Colors.yellow with opacity 0.1. Radius would be width times 2. And then the blur border will be width times 2 as well. I'm missing something. Setup lighting config. My bracket is not closing properly. Is that it? Okay, there we go. Okay, got the lighting config in there. Cool, so the fire now displays the light, but it's not going to be seen until we modify the lighting on the map itself. So we can do that by going to the TheGreenNinjaGame and changing the lighting color theme to colors.black with opacity 0.5. So this means that the map, the entire map will be 50% dim or 50% black, and the light parts where the torches are will display a yellow hue with an opacity of 0.1. So if we refresh this, oh, did I add it to the map? Yeah, I did. Refresh this, you can see the fire on the map, okay? Which is pretty cool, but it kind of sucks because the ninja player, Green Ninja, doesn't have any lighting himself. So to fix that, we can just go back to the Green Ninja player and add a lighting config for him as well, or the mix-in lighting, and we'll just copy and paste the lighting config that was in the fire onto the player. So now, as he walks through the map, he has his own light as well. Another cool feature that you can add to your Bonfire app is a Minimap to display the actual character himself, the NPC, if you choose to do so, as well as the enemies on the map. And it's real simple to set up. We just go back to our Bonfire widget and we use the overlay builder map, which is going to be a map, and we'll specify a key of Minimap that's going to return a Minimap, and we'll just pass in the game. But we can also make a few configurations, such as the margin of where it's placed. We'll do edge and sets all 20. You can also change the border radius, of course. So we'll change the border radius to make it circular. Put 10 on there. And then of course the border, we can change the color of that. We'll make it white with a little opacity. Colors.white.width, opacity 0.5. Okay, so that's the mini map. And then we also need to call the initial active overlays to let the app know that we want to display. Sure. Dang. We want to display the initial active overlays. The initial active overlay that we want to display is the mini map. So just copy that down here. That ain't gonna work. Do it like that. And then make sure that this is a const because we're passing in constant strings. Refresh this. And we now have a mini map of our character and the enemies. I believe you can put the NPC on there too. I'm not sure why he's not showing up. It might be an extra config, but that's the mini map right there. All right, now we can modify the game a little bit to accept different ways. How do I say this? Allow the game to be able to cycle through different maps. I'm going to show how you would set that up. So essentially what you would do is you would create a global function called SelectMap that you could then call anywhere within the app that would rebuild this entire widget because the TheGreenNinjaGame is a stateful widget. And with the widget being rebuilt, you can now update the map or any of the enemies or anything. You can just update it based on the widget itself being rebuilt. So first thing we need to do is we need to call our map ID. Keep forgetting that. All right, call our map ID. So the map ID enum was just levels 1, 2, and 3. So we'll call map ID current map ID equals map ID dot 1, and I'll do the import. And then we have a late function that takes in a map ID called SelectMap. Okay. So if we come down into our widget, we need to do a few things. First, we need to override our dispose method because when we dispose of the TheGreenNinjaGame widget, we would essentially want our map ID to go back to 1. So void dispose super.dispose and then in here we can set current map ID back to map ID 1. Okay. We also need to override our init state method. Init state super init state, and in here is where we will set the select map function. And what that does is it's going to take in a map ID, and from there it's going to call set state to rebuild this entire widget with the current map ID being updated like that. Okay. And then down here, essentially what you would do is you could create a switch statement on the current map ID to like do something like this. Let me see. We're just going to take this entire return statement and put a switch clause right here on the current map ID, and then add all the clauses, and then we'll have a default here. We'll just return the Bonfire widget, but essentially you could do something like this. So if you wanted, when you're on 1, 2, or 3, you could create new Bonfire widgets for each map, or you can just use one Bonfire widget and then cycle between different maps. It's however you want to do it, but this is how you can kind of cycle through different maps for your RPG games. One thing I forgot to mention though is in order to rebuild this widget, you need to add a key to the Bonfire widget, because otherwise the Bonfire widget it will only rebuild if it notices a difference in the widget, but there's not really a change if you just try to rebuild it. But by having a key on it, it forces the rebuild when we hit set state. It has a different key, so it says, oh, this is different, I need to rebuild. So datetime.now to iOS string. There's a much better way of producing keys, but I'm gonna do it this way just for now. All right, cool. All right, so the last and final component to the game is displaying a level 1 screen as well as a game over screen. So level 1 is when the player picks up the coin. Game over screen would be when the player dies. So let's go ahead and create some new screens. We'll go to the lib directory, create a new directory called screens. First screen will be game over screen. This is going to be a stateless widget. Game over screen. I made stateful on accident. Stateless widget. Game over screen. And get the imports. And we need an ID on here that we'll use for mapping this screen widget within the map for the overlays. So static const string ID equals game over. And we'll take out this container. Instead, we're just gonna pass a material widget. The color will be colors.transparent.with opacity 0.5. So we're gonna dim the screen about halfway. Then the child will be a center, and that child will be a column. Main axis alignment will be center. Children are going to be, it's going to be a text field, or not text field, but just text that says, sorry, you lose. Style, we're gonna make it red. Font size will be 100. So it's gonna take up pretty much most of the screen. And then font weight will be bold. Below the text, we're gonna add some space by passing in a size box with a height of 100. And then right under that, the elevated button. Elevated button. And the on pressed is going to call the SelectMap method, the global SelectMap method. And we'll just pass in map ID 1. This is essentially where you could put in a different map ID if you wanted to allow the user to go to the next map. You could pass in map ID 2, 3, 4, whatever it is, but we'll keep it at map ID 1 for this demonstration. Then the child is going to be a text that says play again. We need to import the map ID, add some const here, and SelectMap is going to issue. All right, so that's our game over screen. I'm gonna copy and paste this and make the level 1 screen right now. Level 1 screen, we're gonna change this to be level 1. And instead of saying sorry you lose, it'll say you won, Green Ninja. Change the color to green, of course, and still have the play again button at the bottom. So we got both of our screens now. If we come back to the game widget, we can now add them to the overlay builder map. So we'll have the ID be the key that maps it to the screen. So game over screen.id is going to go to const game over screen. We'll do the same thing for the level 1 screen. Something also to keep in mind is within the select map, I forgot to put set state. So this is needed in order to rebuild the widget. Otherwise, the ID of the current map was getting updated, but it was not rebuilding the widget like it needed to. So there we go. And then last but not least, we need to update when these overlays for the screens are going to be displayed. So the level 1 screen will be displayed when the coin is picked up. So we'll go to the coin method or the coin object. Within on contact, we'll first pause the engine because the level was 1, so we're going to stop the game. And then we're going to use the overlay manager and add the level 1 screen. ID. Do the same thing. Now the game over screen is displayed when our player dies. So we'll go to the Green Ninja player into the die method, pass in the same thing, but it's going to be the game over screen. Refresh this and try it out. So let's see the game over screen first. I'm gonna let them kill me first. All right, screen popped up, sorry you lose, play again. Cool, now I'm going to try to win the game. Yeah, I'm going fast. Just gotta kill the blue ninja to win the game. Oh, oof. Yo, he moving fast. Okay. Let's go. Alright, you won Green Ninja. That is the RPG game in a nutshell. Hopefully this demonstration was very helpful for you and you learned a lot about Bonfire. I'll definitely be playing with Bonfire a little bit more as I learn more about Flutter game development. If you did pick up some gems from this video, please like, comment, subscribe, and let me know any suggestions you have for future videos. Until next time, this is Trey Codes, signing off.